All right, everyone. Section 4.3. This is actually the last section in chapter 4. It's a short chapter. I'm just going to yap at you again today. A lot more talking, a lot of definitions, a lot of things. Today we talk about experiments and observational studies. Why experiments and how to set them up. Like a lot of the other stuff we've done, you're just going to read, analyze, come up with your opinion about why something's good or bad. So cause and effect is an important idea in experiments. Remember in the last chapter I talked about a correlation does not imply causation, that you might have a relationship between something, but is something really causing the other thing? So cause and effect is a certain thing, important thing, or inference. We use experiments to do that. So here's just a quick example. We might have a relationship between children who drink more milk and have bigger feet. So you might draw this little scatter plot and you get this nice strong correlation between milk drinkers and bigger feet. And then the question might be why. And there's one of three different answers for why. Either A, drinking milk causes bigger feet, or having bigger feet, I guess, makes you extra thirsty and makes you drink more milk or want more milk. Or there's some other third thing going on, some lurking variable or confounding variable that's causing this relationship, which we will see in some homework problems too. So an experiment, the whole idea of an experiment is to try to establish some sort of cause and effect. Like, hey, I think that this drug fixes this disease. So we run an experiment to check that. So an experiment is anything that establishes some sort of cause, comparing two or more conditions or treatments using an outcome variable calling a response. So the treatment might be the pill. There could be more than one treatment. There could be like a 50 milligram pill, 100 milligram pill, or completely different pills, something like that. And then you're measuring something which is called a response variable. Okay. So we're going to just talk about experiments, how to set them up, things we're looking for, things we're looking to do. You've probably read about experiments. You've probably done experiments in science. You probably read about experiments in newspapers, things like that. Like, but what's a good experiment? Is it really showing what we want it to show? The vaccine experiments right now are a great example of the COVID-19, how a good experiment works. We'll probably talk about that in class a little bit. So true experiments, randomly assigned treatments. Question I asked there was why, and it's to control for lurking variables. That's the main reason. And what this means is this, is like, if I have people in an experiment that are similar in some sort of way, but can mess up the experiment, if I randomly put them where I put them, they could wind up in either one, and then I just kind of take my chances with that. Weight loss stuff is a really good example for this. So let's say you're trying to test a weight loss pill. A very common lurking variable might be these people go away and they exercise or they eat different, and that could mess up your experiment, right? So if you randomly put them into groups, then you're just hoping, kind of crossing your fingers, and it should work out that they're roughly split up into groups, not all in the same group or something like that. So it gives you a better idea to handle those lurking variables. They also replicate, and replicate doesn't mean do the experiment more than once. It could, but more likely it means you replicate the experiment on a lot of people. So you don't do this weight loss pill on 5 people, you do it on 500. You don't do the COVID-19 test or the vaccine test on 5 people, you do it on 50,000. Okay. And then it also tries to control for lurking variables. One of those ways is to randomly assign, but there are other ways also, which we'll talk about as we go through this. Okay. Before I move along, though, we're going to talk a little bit about an observational study. This should say observational, sorry, an observational study. An observational study is when you use pre-existing groups. So we just say no treatment gets assigned. So in an experiment, you give something to someone. You take people and you say, here, you do this. Here, you do this. Here, you do that. In an observational study, that's already being done. So the conditions are already built in. Maybe we're talking about cancer versus cigarettes or something. So the observational study, you don't go make people smoke. You look at people who already have smoked or already have some sort of thing going on. So that's an observational study. It's a lot harder in an observational study to control for those lurking variables, but sometimes we just have no choice. You can't do certain sort of experiments that would be not ethical, right? Even vaccine stuff is weird. I know there was some talk over the summer, I don't know if you saw it, that people were being actually asked to volunteer to get COVID-19, to like get a shot of it to see how they react if they have the vaccine. But that's a little bit tricky in terms of the ethical piece of that. And so sometimes you just have to do an observational study and you just do the best you can. All right. So it's not as good as experiment, but sometimes you have no choice. All right. So just some words, some definition. Factors are the treatments or the conditions that you're doing. The pill, the 50 milligram pill, the 100 milligram pill, something like that. Like could have multiple of those are called factors or treatments. Okay. And again, the best way to protect against confounding variables or lurking variables is to randomize your grouping. But that's a lot harder to do in an observational study. All right, so let's talk about some things that we go through here. Good experiments. What happens in good experiments? So randomly assigned groups. All right, so once they're in groups, a placebo is an important thing. So I know you've probably all heard the word placebo before. Most people, when they hear placebo, think about like a sugar pill or something like that. Placebo is basically just a group that doesn't get the treatment. It's called a control group. They don't have to get a sugar pill. The sugar pill, the idea is that the idea of the sugar type pill, that kind of placebo, is that so the people don't know that they're in the control group. But some people know they're in the control group. It's not the end of the world if they do. So the control group is just basically people who aren't getting the treatment. Okay, placebo would be we're kind of pretending they're getting the treatment, we're giving something, and that's so they don't go off doing something consciously or subconsciously to mess up the experiment. And another way to handle that is what's called a blind experiment. A blind experiment is an experiment where the people do not know which group they're in. Hence the idea of the placebo, right? So if we're testing this weight loss pill and we're giving a group, maybe there's 3 levels of the pill, 1 pill a day, 2 pills a day, 3 pills a day, or something like that. And there's a placebo, there should be no pills, right? But we don't want anyone to know what group they're in. So you would take the 3 group, 3 a day, they just take their 3 pills. The 2 groups a day would take 2 and then 1 placebo. And then the 1 group, 1 a day, would get 1 with 2 placebos, and the control group would get 3 placebos. No one would know which group they're in, hence a blind experiment, because they are each taking 4 pills. The purpose of that is to control for lurking variables again, or it's also to make sure that people don't go off and do something they think they're supposed to do. And then again, like some people in this weight loss might go, hey, I'm going to eat different, or I'm going to exercise different. If you randomly put them into groups, that's the best you can do. You can ask them not to exercise or eat differently. That's the whole purpose, but sometimes that's a little bit tricky in an experiment. There's also a thing called double-blind experiment. A double-blind experiment is an experiment where the people don't know which group they're in, and either do the researchers. So in other words, I'm giving them their pills, and they're coming back and I'm writing down their responses, or I'm weighing them or whatever. But I don't know which group they're in either. I'm just writing the information down. Now, clearly, someone's got to know which group they're in, right? So the idea is there's some overriding person who's setting up the experiment, puts the people in the groups, say, give this guy these pills. Here are the pills, give them to him. But it separates the researchers from the people who know, so they won't influence the results, or they won't lie or cheat, because they just don't know, right? If I'm just collecting data, I don't know what the data is supposed to show, so I won't mess it up. And the guy who set it up doesn't get to see that data, so he doesn't try to cheat it either. So it's not always possible, but double blind is kind of a good thing. All right, so those are the things. There's actually a 5th one here. I kind of threw something in. This is called you replicate it on as many people as you can. The next thing I'm going to toss in here is just a little definition. Sorry, I got tossed in there. What we call this wording, it's actually called a randomized comparative experiment, if you want the technical term for it. It's a randomized, random is really important, okay? And it's important because it controls for those lurking variables. All right. The placebo effect, I kind of mentioned it earlier. I just want to say something about it. The placebo effect is when someone does something either consciously or subconsciously because they think they're supposed to do that, because they think that pill's supposed to do something. So we do something. So maybe I think the pill's supposed to help me lose weight, so I purposely eat more to make sure I'm not changing my diet, or eat less, or whatever. It doesn't even matter what it is. That would be the placebo effect. I think something's supposed to happen, so either consciously or subconsciously I make it happen. Some people really believe in the subconscious mind. I don't know if I do or not. You might have seen some experiments where they put people in a big party atmosphere group, and then they serve some of them alcohol and some of them non-alcoholic beer, and then they watch the people drink the non-alcoholic beer get drunk, in essence, because they think they're supposed to. Their mind is doing something to them, making them think that. So those are the main things. We'll talk a lot more about them in class as we go through the homework, but those are the main ideas. The last little thing is just other ways to collect data. These are like the 5 different ways to collect data in the statistics or any kind of math world. Census, ask everyone, sample, experiment, observational study, and we're not going to do any simulations. But we do a little bit of simulations, just grabbing numbers. But like if you wanted to simulate like an asteroid hitting the Earth or something like that, you'd have to use a computer to do that. It's simulations all over the place with the COVID-19 stuff. Also, like what's going to happen if this or if that. So most of this stuff is just introductory for you right now. The more you read questions, the more we discuss. There'll be a little bit more discussion in class, the more some of this stuff will come together. So that's it for section 4.3 and actually all of chapter 4. So we'll see you when we get to chapter 5.